In this video, we will analyze a common issue in inverter air conditioners. When the unit powers on normally, operates correctly, and even cools the room in many cases, but then suddenly shuts off. This problem can be caused by several factors, including excessive temperature in the compressor due to overload or failures in the overload switch, issues with the Intelligent Power Module, IPM, such as electrical faults in the integrated circuit or overheating caused by problems with thermal paste or heat dissipation fins. Other factors to consider include defective temperature sensors, faulty electrical contacts, or issues with the manual power switch on the control board of the indoor unit. Electrical problems. 1. Low voltage. Insufficient voltage can force the compressor to consume more current, generating motor heating. 2. Wiring problems. Faulty wiring can generate unnecessary electrical resistances that affect the compressor's power supply voltage. D. Equipment installation problems. 1. Location of the condenser in points of high temperature or near heat sources, increasing pressure and overloading the compressor. 2. Location of the evaporator in places with poor circulation of cold air. 3. Uninsulated pipes or joints that generate unnecessary heat exchanges in the refrigerant, affecting the compressor's efficiency. E. Problems with temperature sensors. 1. When there is a problem with any temperature sensor, there may be a disruption in compressor control, which can indirectly affect its operation. It is recommended to check them using a multimeter on the kiloohm scale. They must be disconnected from the electronic board and their electrical resistance measured, which should not be 0 or infinite, and the resistance value should decrease when the sensor tip is rubbed with the hand. If you have the air conditioner manufacturer's manual, look for the resistance versus temperature table for the air conditioner sensors. Compare the electrical resistance value obtained on the multimeter with the values in the manual for a given temperature. You can also measure if the electronic board supplies voltage to the sensors. To do this, connect the sensors and measure the direct current voltage, which should mark around 2.5 volts. F. Overload detector problems. In many compressors, there is a thermostat located on top of its housing. This thermostat receives a signal from the external electronic board. When the thermostat detects a temperature above normal, it interrupts the circuit signal, allowing the electronic board to identify the presence of high temperature. This triggers a fault code or activates a protection, which shuts down the equipment to prevent potential damage. Also, false alarms due to false contacts in the thermostat or problems in the thermostat itself should be ruled out. 1. Disconnect the equipment from the power supply. Remember that capacitors can store current. Use a multimeter on the DC voltage scale to measure across the capacitors and ensure they are discharged. 2. Locate the IPM electronic circuit. The IPM electronic circuit is covered by heat dissipating fins. Its pins are connected via 3 independent tracks and an electrical connector to the 3 compressor pins. 3. Positive power supply. Identify the high voltage positive power supply of the IPM electronic circuit by tracing the positive track from the largest high voltage capacitors to the IPM electronic circuit. 4. Negative power supply. Identify the negative track from the capacitors to the IPM electronic circuit by tracing the negative track from the largest high voltage capacitors to the IPM electronic circuit. 5. Identify the output points U, V, W. These can be identified by following the tracks, from the compressor connectors to the IPM electronic circuit. 6. Set the multimeter to the diode scale. 7. The IPM electronic circuit is internally composed of 6 IGBT transistors, each containing a diode that we will test. Let's start with the integrity test of the first 3 diodes. A. Place the black probe of the multimeter on the positive input of the IPM electronic circuit. B. Use the red probe to measure the points U, V, W. C. The minimum voltage activation values should be around 0.45 volts for each measurement. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading. Let's proceed with the integrity test of the last 3 diodes. A. Place the red probe of the multimeter on the negative input of the IPM electronic circuit. B. Use the black probe to measure the points U, V, W. C. The minimum voltage activation values should be similar to those obtained previously. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading. If everything seems fine with the IPM electronic circuit, you can perform the following test. Before intervening with the IPM module, ensure the following. Verify the correct positioning of the heat dissipation plate over the IPM. Check the condition of the thermal paste that contacts the dissipation plate.